Hello everyone, in this video we are going to explore how sediments turn to sedimentary rocks. So how do sediments turn to sedimentary rocks? Well, by a process that is called diagenesis, sediments turn to sedimentary rocks. Something that is included in diagenesis is lithification. Lithification is the process that turns weathered sedimentary material into sedimentary rocks. Or in other words, it turns sediments into sedimentary rocks. We have two types of lithification. We have cementation and compaction. In later slides, we'll explore each of these processes. But first, let's start with diagenesis. So what is diagenesis? Well, diagenesis is the change that can occur to sediment from the time it is deposited until it becomes sedimentary rock. When sediments get deposited, they get heat and pressure, and due to this heat and pressure, they change and they become sedimentary rocks. Usually diagenesis happens in the upper few kilometers of the crust because at that region pressure and temperature is quite enough to turn sediments into sedimentary rocks. And just so you know, diagenesis comes from the Latin word dia and genesis. Dia means change and genesis means origin. So as I mentioned, diagenesis happens in the few upper kilometers of the crust under temperatures of 150 to 200. In that upper few kilometers of the crust, the temperature is just right enough for sediments turn to sedimentary rocks. So now let's explore the process that turns sediments into sedimentary rocks. Well, we have lithification. Lithification is the process by which a consolidated material turns to solid sedimentary rocks. The process that changes sedimentary material or unconsolidated material to solid sedimentary rock is called lithification. The exact opposite of lithification is weathering. Weathering, as we mentioned in previous lectures, is the process that changes sedimentary rocks into unconsolidated material. We have two types of lithification. We have cementation and we have compaction. Cementation is the crystallization of minerals between grains. When we have unconsolidated material and grains in different types and shapes, there are crystals between these grains. As we can see right here, we have a big grain here, we have a big grain here, we have a big grain right there. When these minerals between these big grains get crystallized, cementation occurs. We have three types, or actually we have three main types of cementations. We have calcite cement, we have silica cement, and we have iron oxide cement. These are the most common cements that you can find in sedimentary rocks. The way that we can find whether a rock is cemented in calcite or silica or iron is very easy. Iron oxide usually gives a red color to the rock. Silica, on the other hand, is a very strong material and it creates the strongest sedimentary rocks. This is how you can find it. Calcite, on the other hand, is very reactive with acid. If you have a rock that is cemented in calcite, all you have to do is pour acid on it, and if it fizzes, then it's a calcite cement. The other type of lithification that we have is compaction. Compaction is the process by which sediments lose the porous space in between as the result of loading on top. So imagine these are the grains that you have and they are being compacted. What happens is due to load on top, the porous space between the grains get decreased and therefore compaction happens. This is sediments before compaction. This is sediments after compaction. After they are compacted, the grains get closer to each other and they become a sedimentary rock. Compaction is very important because by the process of compaction, water that resides in between the porous rocks get kicked out, and therefore you get a very solid material, or you get a very solid sedimentary rock. If you can remember, in previous lecture we mentioned that coal, after it gets compacted and then heated, you get the best coal, that is, and it's called anthracite. The reason you get the best coal is because due to the compaction, the water that resides in the porous space of the coal grains get kicked out, and therefore you get a very solid material that can give a lot of energy. So to recap the whole lecture,